So I'm looking at the problem Salesman from IOI 2009. So I'm looking at it for the first time right now. Let's read the problem. Oh, let's start the stopwatch too. Cool. The traveling salesman has decided that optimally scheduling his trips on land is an intractable computational problem. So he's moving his business to the linear world of the Danube River. He has a very fast boat that can get him anywhere to anywhere along the river in no time. But unfortunately, the boat has very terrible fuel consumption. It costs the salesman $U for every meter traveled upstream and $D for every meter traveled downstream. It's away from the source. Okay. There are N trade fairs that the salesmen like to visit along the river. Each trade fair is held for only one day. For each trade fair X, the traveling salesman knows its date, TX, measured in the number of days since he purchased the boat. He also knows the fair's location, LX, measured as the distance in meters from the source of the river downstream to the fair, as well as the number of dollars, MX, that the salesman is going to gain if he attends the trade fair. He has to start and end his journey at the waterfront home on the river, which is at location S, also measured in meters downstream from the source of the river. Help the traveling salesman choose which trade fairs to attend, if any, and in what order, so that he may maximize his profit at the end of his travels. If the traveling salesman's total profit is defined as the sum of the dollars he gained at the fairs he attended, minus the total sum of dollars he spent traveling up and down the river. Keep in mind, if the trade fair A is held earlier than trade fair B, the salesman can only visit them in this order. This means you can sort, it looks like. However, if two fairs are held at the same date, the salesman can visit them both in any order. Okay, that makes sorting a little harder. There is no limit to how many fairs the salesman can visit in a day, but naturally he can't visit the same fair twice and reap the gains twice. He can pass through the fairs he already visited without gaining anything. Write a program that, given the date, location, and profitability of all the fairs, as well as the location of the traveling salesman's home and the cost of traveling, determines the maximum possible profit he can make by the end of his journey. Okay, so you have the cost of traveling upstream and downstream is only less than 10, and that's a very small number, so that's interesting. Input, let's see, NUS or UDS, and the next N lines contains the fares. Okay, so it says the date of the fare, the location, and how much money you can make from it. All the locations will be different. That is, no two fairs will happen at the same location and no fair will happen at the salesman's home. That is quite interesting. Okay, so the location of the fairs are up to 500,000. And the money he earns is also 4,000. So it seems like these cost values are very tiny. Okay, I'm gonna try to calculate what is the max money he can get. Okay, so let's just say he attends all the fairs. And each of them he gets 4,000. This is 22 billion. Okay, so looping through the whole entire money is definitely too slow. Oh, I guess this is the cost of traveling 1 meter. And so you can travel 500,000 meters, so that's like 5 million for everything, for each travel. Okay, that's a bit high. Alright, so let me go what I was thinking earlier in terms of sorting. This is because the order has to be previous day to next day. unless they're on the same day. Okay, let's just say, I say, and this is obviously too slow, but it's just the first thing. DP event equals min cost. Oh, we don't want the min cost, we want the maximum profit. Maximum profit ending at this event. Because our answer is the maximum profit, so we'll make our DP equal to the maximum profit. Okay, and we know that our location, let's keep it in black. The location for DP event is the location of the event, because we're going to this event. Okay, now it's in somewhat of an order. So let's just say that two fairs are never held on the same day. Then DPI would be calculated before DPI plus 1, and so on and so forth. Now you have the issue that two fairs can be held on the same day. So this makes it a little more tricky. Let's just say we have DP day location, and of course the location has to be the location of one of the events, equals max profits ending at location. And I'll just put this over so you can see the whole thing. Okay, I'll put a look. So max profit ending at the location. Now the states right now looks really high because you could have 500,000 days and 500,000 locations. However, keep in mind that the location has to occur on that day. So this is the total number of states equals to the number of fairs. So we're not going to store all the locations for all the days. We'll only store a subset of them. Maybe with like a vector or something. But our total number of states will equal n. Okay, now that our states is a good number, okay, so our states is a good number. Now we just need to do our transitions. Okay, so let's first think about the transitions if there is only one fair per day, because that'll make it so much simpler. I, j, and there'll only be one value of j for I if there's only one fair in the day. This will equal to the max of, okay, so you have a previous I2, J2, plus however much money you make, that's called M of I, so how much money you make at I, minus the cost to travel from J to J2, and this is the max for all pairs of I2, J2. And again, I2, J2 will be a max of n pairs, or less than n pairs, because not all the days have all the locations. Like the total number of locations times days, or for is n. Okay, this runtime is n squared because this max function takes n values here, and there's n states. So the runtime currently is n squared. Oh yeah, but this is not even fully correct so far. This only accounts for if there's only one event per day. There could be more than one event per day, in which case you have to try different order. Okay, so it seems to me that if there's more than one event per day, let's just say you have an event at locations 3, 5, and 8, you're either, and let's just say, just put like more. And these are all in sorted order. If you sort the order, let's just say you decide you're doing a continuous subsegment. You're going to do a continuous range because from the previous day, you're going to come somewhere. Let's just say you start at 8. You're either going to travel left or you're going to travel right. Now, let's say you want to travel both left and right, you could just start at 3 and only travel right, and it'll cost the same. So we'll just consider that we take a continuous range, and there's no point in going to a location and not gaining the money because you're traveling past it anyways. So we'll take a full continuous range. And so yeah, from the previous day, from day -1, we'll start at one location and then we'll end at the other location and then we'll go to day +1. Okay, now the thing is there are two options. Option 1 is you start somewhere on the left. So say you start 8 and you travel to the right. Option 2 is you start somewhere on the right and you travel to left. Oh, you don't start on the right. You start somewhere and you travel to left. And option 1 is you start somewhere and you travel to the right. So what we can do is, I guess we could split every day into two 2 DP cases. So the first thing we'll do is we'll have DP day lock equals max profit to reach lock. Oh yeah, DP day lock 0. On the day. And then DP day lock 1 equals max profit to end at lock on the day. Okay, so basically like in node, out node. We travel into here, into DP day. From DP day 0, we travel to DP day 1. From DP day 1, we travel to the next day. Next day 0. Okay. Now, now this takes care of if you have multiple events in the same day. Let's go back up here. DPIJ equals max DP. It's a good thing in red, right? So the thing is, we don't necessarily um we don't necessarily care about the previous day. We just care about the previous location, right? Because it's not like it takes us a certain time to travel, a certain number of days to travel. Seems like we're able to travel instantly, and we only care about the previous location and the current day, of course. Because nothing in this formula here uses I2. It says for all I2 and DPI2, we don't care about the specific value of I2. Like, it's just a way to find the different location. So this means that we only have to loop through the other locations. So, it's a tricky problem. Alright, so let's just say that DP day lock 0, we calculate this, and then we calculate dp day lock 1, and then, so we'll have these as temporary dp arrays. TDP 0 and TDP 1. Okay, and then our actual DP array looks something like DP lock equals max profit ending at this location. Okay, and of course, this is on a previous day. But we don't care which previous day, it's just on a previous day. Okay, cool. So now we need a formula to calculate TDP 0 and TDP 1. Oh yeah, and we can erase day. It's just a temporary array that we delete afterwards. Or we change afterwards. We don't care about it afterwards. Here, let's change the name to TDP 0 and TDP 1. Okay. TDP 0 lock. Oh yeah, and this current location, it has to be the location of an item or an event on the current day. So the total number of states we're calculating still is O of n for all the days combined. So we're not looking through all locations, we're only looking to the ones on that particular day. Equals, and I don't think we'll count, we won't count the profit right now. So if we're not counting the profit right now, this is, sorry, we don't count the profit of the current day. So this is max of all dpj plus the cost to travel from j to lock for all j. Okay, and TDP1 lock equals the max of all TDP0 j plus the profit of everything in the range from lock to j for the current day minus the distance to travel from lock to j. And anything else? I think that's it. Oh yeah, for all j. Okay, and then I suppose dp lock equals max of whatever it currently is for TDP1 lock. Okay, so it looks like we have O of n states, and everything's coming out to O of n. The only thing that's not coming out to O of n is the for all j in these two formulas here. So we need a way of quickly calculating dpj plus travel j lock. This is the tricky part. Okay, so it seems like traveling upstream and traveling downstream have different costs. Is there some way we could use a segment tree or something? This sounds like a segment tree problem because you're supposed to maximize a current value. Alright, I'm gonna look at this formula right here. Okay, so let's see if I were to make a segment tree. Okay, let's just say, oops, the travel is different if j is less than l, or j is less than lock and lock is less than j. So let's just say, and this is the difference from the upstream. So let's just say that lock is less than j. This means we're traveling upstream. So then this formula would look like dpj plus the travel from j to lock would be j minus lock times u. U is the cost of traveling upstream, I believe. Yes. Which equals dpj plus u times j minus u times lock. So this means, so this is actually very good because this stays constant no matter what lock is. This value for j stays constant. So this can be put in a segment tree. And this part can be simply calculated, or I can put a negative with it. This part can be simply calculated using the value of location. So this means that we're simply trying to query, and this is constant for the, this part here is constant for the value of lock. This means we're simply trying to query the max value of this for all j greater than lock. So we can put these in a segment tree, size of the segment tree being 500,000, the locations of, or 500,001, I suppose. Is there anything okay, so it can't be at 0, so yeah. And I think we could do the same thing for this other TDP1. We can say, what did we say here? Okay, so the formula equals, oh, so for this formula we're taking this profit here. Okay, so, well, at least we got this TDP0 down to logarithmic. Okay, for TDP1, okay, let's consider this formula profit lock j. If I were to create a prefix sum array, if I were to create a prefix sum array for profit, so let's just say I had a location, they had locations 3, 5, 7, 10, and the profits were something like 6, 4, 4, 2, and so the prefix sum array would look like 6, 10, 14, 16. Now if I were to have a prefix sum array, and would be the index, we'll use a map of some sort, I don't even know. Then this formula becomes TDP0 of j plus prefix sum of j minus prefix sum of lock minus 1, or whatever the previous index is. Oh, did I minus the travel here? Okay, so it looks like I have to subtract the travel instead of add it. But nothing should really change. Yeah. Travel, you lose money. Okay. So I have the TDP0J plus the profit, which is the prefix sums, minus the travel is oh yeah, and just to be clear for this is if lock is less than j. If lock is greater than j, we just do the equivalent thing, just using d instead of u. You do it uphill. Okay, the travel is, let's just say that actually let's do the opposite. Last time we did this uphill, this time we'll do this downhill. So we'll say last time lock was less than j, this time lock is greater than or equal to j. Actually, it can never be equal. Okay, lock is greater than j. So this means that we are traveling downhill because we started at a smaller value and we're now at a bigger value. So it's d times lock minus j. Previously it was j minus lock because j was bigger. Now it's lock minus j because lock is bigger. Okay. This equals TDP0 j plus prefix of j minus or plus d times j minus prefix lock minus 1 minus d times lock. Okay, now this is important because these values can be put in the segment tree because they're dependent on j, and these values are dependent on lock. Alright, I think I have a good working solution, so let's start coding this. I'm going to use my defines. It's really inconvenient for me to code without them, but they're pretty straightforward. I have a couple loops defined here, and general for loops defined here, and define it long. I don't think we'll be using the pair stuff. Oh, and there's some print defines. S is space, C is colon, W is right, E is n-line. Okay, so first thing is max n is 500,000 and 1, which is very specific. Actually, it's less than equal to 500,001. So the location, I'm just gonna put 500,002, and not worry about it. Okay, let's get in the sample. And then okay, the next thing in the input is the fares. So they give it in the day, location, and profitability. And N is up to 500,000. Okay. I'm reading it as pairs so that I can sort them easily. This loops for I0N. Okay, the next thing in the input. Oh, I think that's it. Cool. Alright, so the formula I was using goes for every day. Like the DP thing, it works if I do it per day. So okay, now the day, or the fares with the same day, are I through j. And then at the end, I equals j plus 1, because that's the next day. Cool, so let's see, what was the first thing I needed to set? Right, TDP 0, the max profit to reach location on the day. TDP 0, oh yeah, I should first create my DP arrays. Okay, DP lock, max profit ending at this location. It's fair to assume that everything starts at 0. Actually, does it give you the location that you start at? He starts and ends at S. That means originally, all the DPs should be negative infinity, and then DPS equals 0. Probably 2018. Okay, so then the next thing I need is TDP 0 and 1. and these things seem like they have to be reset every day. Not exactly sure how to reset those, but I guess I'll figure that out as I'm coding. Okay, and then it looks like I need 2 segment trees. Do I need 2 segment trees or 1 segment tree? Okay, for if lock is greater than j, then the segment tree needs to store TDP0j plus prefix j. TDP0 needs dpj minus uj. But if lock is greater than j, then it'll need dpj. Then it'll need something different, right? If doc is greater than j, then we're traveling downstream. Then this is dpj minus travel. Okay, so dpj minus the travel is now lock minus j times d. This equals dpj plus dj minus d times lock. So then the segment tree would store, I need a second segment tree that stores this value. Okay. If lock is less than j, then this formula comes out to TDP0 j profit lock j, but lock is less than j, so this is plus pre j oh, here lock is greater than j, so this should actually be pre-lock. And this should be pre-j minus 1. Because lock is greater than j. Okay, here it should be pre-j minus pre-lock minus 1. Minus the travel would be, so here I'm going, if lock is less than j, then that means that going down, I don't know, I think I'm, because on top it says, what did I put here? If lock is less than j, then I'm going upstream. That sounds about right. Oh yeah, and to change that I have to change it in this pink formula here. Okay, so then this equals to TDP0 j plus pre-j minus uj minus pre-lock minus 1 plus ulock. Okay, and then the segment tree stores this value here. And then of course this is the second value. Okay, so then I need 4 segment trees, one that stores TP or TDP0J minus pre-J minus 1 plus DJ. But the problem is that it's not exactly pre-J minus 1. It's well, I guess it in a way is, but the prefix sum changes based on lock. Okay, so these two values can both be put in a segment tree, dpj minus uj and dpj plus dj. And so can plus pre-j. Actually, pre-j can't even be. Both of these two pre-values cannot be placed in a tree because prefix changes based on the day. I suppose since the number of prefix values that we're changing is O of n for all the days combined, then we could just find our prefix values and we could have a tree that stores TDP0J plus DJ, and then we just subtract pre-IJ from the particular values, and then we can just query. So that'll work. And the same thing for down here. We could just add in pre-J on the current day and then subtract it when we leave that day. Okay. So now I think we have a better solution. Or correct solution. Alright, now I need to make the segment trees. Let's see, what should I call them? Okay, I think I'll call the ones here T, remove DP 0 D. So this TDP plus DJ. And I'll call the next one T0 U. And then the bottom two can be called DPU and DPG. Okay, it seems like I'm only updating individual values, like I'm never going to have to do a range update, so I don't need a lazy propagation, which that's nice. Okay, I'm going to remove the long because I'm using a lot of memory already. Actually, is there a limit in the problem statement about how big I should make infinity? Okay, the cost of traveling is 10. Or actually, the number he can... Okay, so the DP equals, I think, max profit, right? Look at the definitions. Right, so there are a total of 500,000 fares, and the max profit you can make per fare is 4,000. So that comes out to 1, 2, 3, 6, 7, 8 zeros times 20, which is 2 times 9 zeros. So does this compile? Cool, that compiles. Okay, so you got a good infinity. Alright, wait, I need a second. I'm just gonna run it to see approximately what the runtime looks like. Sometimes, okay, cool. Sometimes when the memory is really big, the runtime is just super high. This means that the memory is not excessively big, which is nice. Yeah, I suppose 4 times 500,000 is just 2 million. So this is about 8 million. It's not super bad. Okay, cool. Now for every day, I need to. The first thing I do is I find TDP0, which is the max profit to reach the location on the current day. And a TDP0, the formula for that is cool. So we need to do 2 separate queries. One considering that location is greater, or j is greater than location, which means traveling upstream, and the other is traveling downstream. Okay. So oh yeah, first thing I need to do is I need to, well, okay, what should we initialize TDP with? I suppose negative infinity. And we should probably initialize all of these arrays here. They all involve some sort of DP value, so I guess we just initialize those to negative infinity too. Okay, now, so I'm just using j here, so I'm just gonna pick a different variable here. I'm gonna say k, just so that it's a bit clear with my. Can I move for L from I to j plus 1? This is all the values on the current day. It's not inclusive on the right end, so I have to put j plus 1. Okay, location, lock equals dp l dot b dot a, and then I want to get the max value of uh, for all j that is greater than location. So I want to query, and this is dpu. Yeah, I'll just call it the function query dpu. Okay, this is j is greater than location, so yes, that would be the range, I suppose. And then j starts at, or we start at lock plus 1. That should be k. We start at lock plus 1, and we go to the end, I guess. And we try to query the max value. So is our seg tree query? This will give us the max value of this. So now we say that EDP or not TDP. Yeah, TDP. I think it's TDP lock. Yeah, TDP 0 lock equals, this is the max value it could be, plus U times lock. Okay, so this should set all the TDP. Or, actually you have to take a max of the two values. TDP 0 lock equals max. Oh yeah, let's put the max here. Okay, the other option is we query for all j less than lock. We query dpd from 0 to lock minus 1. Actually, what is the case if j equals lock? So this is dpj minus travel, right? So if it's equal, then it would be 0 travel. So we have to include the case that it equals somewhere. Let's just put it here because we didn't code this one yet. This thing will load. There we go. Okay. Query dpd 1 0 minus 1. That's the range. We query from 0 to lock. And then minus d times lock. Okay. Now we got TDP 0 set. Okay, one job done. Now we need to, oops. Now we need to do TDP 1. And TDP 1, recall, is the max at the end of the day. So TDP 0 is the max at the beginning of the day. So we'll just loop through again. Oh yeah, and we also have to update the value in the seg tree. So, okay, so it looks like we don't even need a TDP0 array. We just need to update the value in the seg tree. I'll just say, so we update, and this seg tree is called T0D. One zero max in minus 1. And we update the location to be TDP0 plus D times J. Okay. And we'll update subtracting pre of J later. And then we also need to update for this bottom one here. Oh, that's T0U equals TDP0 minus U times J. Okay. I'll write these functions later, I suppose. Now, we just need to set 1. TDP1 lock, and we might even be able to erase the TDP1 array and just make it a single variable. But for now, right now, I'll just put it in as an array value. This equals. Oh yeah, and we need to put in the equal sign somewhere. Oh yeah, I remember why I didn't put in the equal sign earlier, because we determined that, because it says in the sample that, or in the problem statement, that two of them can never be on the same day. Or no, right, two fairs cannot be in the same location. New fairs will happen at the same location. No two fairs off the same location. Okay, cool. So we don't need to take care of the equal sign here. Where was that? Okay. Actually, I suppose we could just include j everywhere, because we know it's not going to happen. Simply because we don't want lock plus 1 to be greater than maxim minus 1, and we don't want lock minus 1 to be greater than or less than 0. We'll just include it everywhere. Okay, so the first thing is query 0d. Oh yeah, we first need to update it with the pre-value, so I'll just put that as a comment here. And then I'll add that later, I suppose. Okay, this is lock is greater than j, so j is less than lock. Okay, yeah, so we query the max of all those, and then we add pre-lock. I'll put that as a comment, because I'm not exactly sure how we're going to do the prefix sums yet. Minus d times lock. Okay, and it's the max of this one query here, and the second query. What is this? Okay, cool. This is query T0 U, and this is lock is less than j. So this is recurring lock to max n minus 1. And then we have to do minus pre this is press pre lock, and this is minus pre lock minus 1 plus u times lock. Okay, and I'm just gonna look at the formula for dp. Where do I set dp? Okay, dp lock is max of what it currently is, and tdp1 of lock. Okay, I think the thing to realize here is that since no two events ever happen on the same day, we can just say that dp lock equals this, because dp lock originally gets set to 0, and so the max of tdp1. So dp lock will always be negative infinity the first time you see it, because each location only occurs once. Okay. And then I'm gonna do the reset values. And these are only for the updates that I did. I just have to unupdate them. Oh yeah, and do I have to update the DP values anywhere? Okay, I do have to update the DP values, but those are permanent updates. And then I have to just reset these two. Alright. She updated all of our trees, and then we just have to unupdate these two trees here. So I'm just gonna... Actually, TDP comes from... Or, okay, TDP is used for DP1. Does it matter if I unupdate them? I think it does, because... Oh, I think the stopwatch went into an hour. Yeah, okay, I'm just gonna... Oh, I'm just gonna leave it like this. Okay, now I just need to do this update with prefix values thing. It's a good way to implement this. Let's see. Well, first I'm using them here, so I might as well keep this open. Okay, I'm just gonna make the prefix array global. And then I'm just gonna set the values from I to K. Oh, this should be DPL. It should be everywhere. It should be DPL, not DPK. Plus prefix lock plus prefix L. And then over here, when you have minus prefix lock minus 1 and minus prefix L minus 1, I think we'll do this. Phi is not equal to 0. Prefix I minus 1 equal to 0. And then we'll just put a value for this. Okay, because prefix L minus 1, L could be 0. So pre L minus 1 equals, if L is not equal to 0, then pre L minus 1 equals prefix L minus 1. Okay, there we go. And this value here should be pre L1. Okay, I also need to update pre-j minus 1 and pre-j to the different DP arrays. Okay, so here I'm simply okay, I think what I'll do is I will set up the prefix some values before updating that. So then I don't need to set up a separate thing for that. And here, TDP0 plus DJ minus, okay, so here's which one's easier. This is plus prefix lock. And it's not J, it's lock. And then here it's minus prefix J minus 1. So do the same thing we did here. This should actually be lock minus 1, so that's fine. If is not equal to 0. Oh, this should be L, actually. This should not be lock, this should be J. Okay. I think all of these are right. And then what we'll do at the end is okay, I'm gonna make this 503 or 500,003, and then I'm gonna say fares n dot a. So the day is day we never leaves. I'm gonna say max n plus 1, just to make it. Let's make pair. Okay, max n plus 1. The location is S, and the profit is 0. And then n plus plus, because we have 1. And this is just so that at the end, I can print the min cost or the max profit if I end up at S. And they said that there'll be no events at S, so all the stuff that's here should work. Okay, now I only have to write the update and query functions for all 4 arrays. And it seems like the update I'm doing is not an added to set. Okay, so basically I'm setting location X to the value Z. This means I'm on the right value. Oh, it's not tree index. It should be. Which am I updating? Let's say I'm updating DP. Okay. Now I just need to repeat this. Just making sure that none of the same values show up. Cool. What other arrays do we have? We have T0U and T0D. Just make sure that cool. And the last one is T0U. Cool. So I got all my update functions. Now I just need to write the queries for all of these. Means if you're not in range, this is the max I'm returning negative infinity. This means that we are completely in range. Cool. Okay, let's see if this builds. And 15. 103. Oh, this is fair. 104. 106. Okay, well, at least it built. That doesn't look good. Should be 50. Okay. Oh, okay. Here's the thing. I said DPS equals 0, but I didn't update the corresponding seg trees. I need to update. This thing will load. I need to update. Still on. Okay, there we go. I need to update the DPU and DPJ. Still negative. Okay, I'm just gonna make sure that it actually got updated. And this should output negative u times whatever s is. It should be negative 5 times s is 100. Right? Okay, so negative 500 is correct. So the update function and the query function looks like they're working fine. And they're all copy pasted, so that's good. Make sure everything's pasted properly. Okay, and I'll use this. So let's look at the input again. All the days seem to be different. Make sure everywhere I access prefix is fine. Because I remember I had to change some of the indexes. Yep, they're all L minus 1, and they all should be. Should be the L or N minus 1, or L minus 1. Okay, let's write block base CPU. Block is 80. You know what, let's just write block space TDP 0. Because one of these two should include S, which is 100, right? In fact, this block is 0, then it should be included in this one right here. Okay, so TDP 0 seems to have decent values. And then TDP 1 seems to have these insanely valued. Okay, let's just print out the values that I'm changing it to. These are also looking like decent values to be changing it to. And here it's inclusive, so it should be including lock and both. Okay, I'm just gonna print more stuff here. Okay, so I'm updating lock in, this is for TDP 0, right? I'm updating lock to 140 if the maximum is negative infinity. So let's see, update TDP 0. Wait, I'm setting this to T0D, right? Something on the right. Oh, this should be plus 1. Probably the same number. Oh, yeah. And 50 is the right answer. Cool. So I'm just gonna comment out all these prints. Okay, so looks like I got some right, some wrong. Oh, no TLE, which is a good thing. It looks like up to 18 out of 30. Got most of them. Look at their subcases to see. $60, which is, I mean, I guess 18 out of 30 is about, it's about 60 points, I think. Wait. Oh yeah, 60 points. Cool. So I got most of them where they're not held on the same day. Not all of them. Okay. Wrong answer. Just check this to make sure that my update functions are right. I mean, they look right. Let's try a case where the maximum profit you can make is 0. Let's say n equals 0. Print to 0. Profit you get from anywhere is 0. The output to be 0, but I feel like it is 0. Well, before we tackle the remaining wrong answers, which are on different days, I assume, ones where they're all on the same day, or they're not on the same day. Just making sure the day doesn't matter. The prefix sometimes looks right. Okay, let me just try to figure out if the value of infinity is okay. So the maximum you can gain is definitely right, but the maximum you can lose, if you're costing 1 per unit, and this is a maximum of 500, that's 5 million for one travel, times 500,000 again. So yeah, that's probably too big. The max you can earn is a better estimate, I think. Okay, since we've given these values here, I think I'm just going to print all the DP values. Okay, he attends fair number 1. Fair number 1 is at location 80. It earns $100. Profit so far is 0. But at our 80, it says negative 90. Oh wait, I change this. Okay, 80 is good at 0. He travels 5 meters upstream and fence fair number 3 at location 75. Profit so far 125. Yep. And then he goes to location 100. Profit at the end is 50. That looks all good. What if the cost of traveling was just excessively high? I know it actually can't be that high, but I'm just gonna try it. To see that we cannot ever have negative numbers. It's interesting this is always okay. Oh, I guess because we're updating it at the beginning. Yeah, we're querying DP and since there's 0, we do plus u times lock. So when this is s, this becomes 0, and this becomes minus u times lock, which is also 0. Alright, cool. So these are all good. Oh, so then it'll be a negative number. Idea. Okay, let's try if we have 5 cost 1 to go upstream, 1 to go downstream, and we start at 0. So went 1, 2, 3, 4, 5. Let's see, location 1, 2, 3, 4, 5. You gain 1, 2, 3, 4, 5. The optimal option would be to go down to 5 and back. Cost would be 10, but the profit would be 15. So you would gain 5. Okay, well this looks good. It does say source in NZS, yes? Yeah, he starts and ends at location X. I can check this max end because it says the day is up to 500,000, but that won't really make a difference. Okay, I'm not really sure what's causing this, so I'm just gonna get the test cases. Okay, so pretty sure their 0 corresponds to 1, so their 6 here is 5. Okay, so the answer is, I should rebuild this. Oh no, I should comment this out. $1,000, okay. I'm off by 4. Let's print that. Well, that's a lot. Okay, let's look at the test data. It's supposed to end up at 3, and it costs 9 to go upstream, 8 to go downstream. So I assume that, let's see, this means I have to go 4990 at a cost of 9, negative, and then 38425. Oh, that's okay. So from here we can't go. Interesting. And this, okay, wait, so if we're at 6 and we go downstream, we subtract 27 and we get to 3, and the answer is 1004, right? Just because 31 minus 27 is 4. Okay, this is partially good. It means that, I mean, at least I found something that leads to the answer. Okay, so we have that, and this would be going downstream, right? So it would be updated to, oh sorry, going upstream. So we would update 6 to this minus 18. Not 18, it would be 6 times 9, which is 54. Okay, 997. So that value would be updated too. And then when I query it for here, we would be querying the UD, or querying DPU. And so we would get, let's just say, this value, and then we add U times the current location, plus U is 9 times the current location 3, 27, and that gets 1004. Just to make sure this is correct, I'm just going to say if lock equals S, write TDP 0. Oh yeah, we don't need to print all this again. Okay, this is, alright. Let's print this. What? Oh yeah, it should be 977. If it's less than that, we have an issue. Yeah, okay. So we said that when it was 6, oh no, not 0, 6, by the way. One oh three one. That is what we want. Then I'm just gonna move this here. And this should be 99 or 977. Yeah, okay. And this never gets undone. Alright, let's just query. Let's see, this is querying from S to maximum minus 1. And we know that S equals 3, so this is part of the range. This should also be 977. Okay. So it's working. It's working here. I don't know why it's not working here. It's negative infinity. Wait. Okay, so you only update 6 one time. Oh, this is DPU here. And this should be TU. But I checked all that. Yeah, there we go. Okay. I'm just gonna try some of the other cases that we got wrong. See if they're now right. Like the last test case. Okay, it looks right now. Yes, nice. Took almost 2 hours. Wow.